Today the plan, I will definitely want to finish the aggregation and composition. It's mainly just about discussing, visualizing the objects, how they interact with each other, especially got aliasing. That's basically the thing for today. And I do want to finish these two topics so we can talk about inheritance, which is the most important part of the course from my point of view. Okay? If we cannot start inheritance today, we definitely start on Monday for sure. Okay? Okay, let's see. Aggregation composition. That's kind of the example that we did just on the slides. Okay? Let me just remind you one more thing before I start tracing. There'll be lots of examples today to go through. Okay? Hopefully you won't get bored. I really hope. That's kind of the notation we went over last time, so you can review that yourself. Again, whenever you see two classes over here, it can be between course and faculty, or it can be between students and course. If you're given a diagram, whenever you see the empty diamond over here, it simply means contains. For example, a single course contains a single faculty as its professor. Okay, that's how you read the diagram. Okay, we talked about it last time. And the way to implement it would be under the course class, you got a prof of type faculty. Okay, that's what you'll see. And to make it a little bit more complicated, you say a student contains multiple, so star means multiple. And usually you implement multiple using array. Multiple course objects as its courses. To implement that, you will simply see under student class, we got courses of type course array. Of course, you can also use array list that we talk about, or you can use linked list in the Java library. That's not a problem, okay, if you're not strictly forbidden to do it. But we'll see examples today. Okay, so let me go back to, so this is this example that we went over last time just for the code. I'm going to trace it. Let me remind you very quickly, okay? If you look at the course class over here, course has a title, it has a prof, which means at the runtime, every course object has an attribute called prof, which stores the address of some faculty objects, right? You will store the address. That's what you'll see. So this first example will be very easy just to warm you up. So just about visualizing object. Let's do that anyway. And I want you to pay attention to, for every example we're going to go over today, think about aliasing. Okay, that's a main concern today. Okay, and let me just summarize something for you. When we talk about aggregation, aliasing is allowed. When we talk about composition for the second half of the lecture today, composition should be where aliasing is forbidden. Okay, it's completely opposite, but we'll see. Okay, let's go over the code over here. I also showed you the code last time, but let's go over line by line quickly and see how we can trace it. Okay, let me go to iPad here. So now we talk about two kinds of objects over here. We have the faculty objects. Every faculty has a name. Make it easy. And also every course has a string title and also the address of some professor being the faculty, right? That's kind of what we know, okay? So now let me trace it quickly. Okay, let's go line by line and then let's see. Okay, if you got any questions, just let me know. Feel free to interrupt me. Let's start from line 1. Line 1 and line 2, we are basically creating two course objects, EECS2030, EECS3311, with the corresponding title over here, okay? I'll make myself a little bit easier so we don't get too messy diagram. So what I will do is, I will create one course object over here, and its name is simply EECS2030, right? It's pointing to it, and then it has the title simply Advanced OOP. Okay, that's the title. Okay, it's a string. Okay, and then the second one over here is basically going to be 3311, which is another course. In that case, it's going to be EECS 3311. 3311 is pointing to this particular object, and the title is different, of course. And then we're going to have software design. Okay, question for you. Up to now, what will be the value for the prof? EECS2030.prof and also EECS3311.prof. What would be the value? Null, exactly. Hasn't been initialized yet. Very good. Okay, well, we're going to see how we can have aliasing in just a moment. And then after this, we're going to create another object here. Let's say we got faculty here, prof, and then let's say myself. Okay, so what I will do is I'll just create another faculty object over here. Let me just move this guy here a little bit downwards. Okay, so we can have some space. Oops. Let me just do it again. Okay, that's good. So I will paste the faculty object over here, and then let's be consistent with the name, it's prof. Okay, it's pointing to this faculty object here, and it's myself. Okay. All right, so far so good. So now let's focus on these two lines. Line number 1, line number 2. Okay? So now over here, when we say the two courses, we want to set a prof. And if you refer to the setProf method over here, you're simply going to say this.prof is assigned to whatever argument you give. So you're really copying addresses, right? That's what we learned before lab test 1. Okay, so now if you try to do the first one over here, let's see what's going to happen. The first one here is going to say prof is going to be the prof over here. And then the context object is EECS2030, right? So we're going to say EECS2030 over here, the prof is set to be this particular faculty objects. So now, do we create any new object here? Do we? Or we simply assign addresses? Assign addresses, very good. Okay, just make sure. So what we will do, it shouldn't be too strange to you, we simply assign EECS2030, the prof will be this object here, right? And similarly, when we do the next line, 3311 also say prof. And then I'm just going to say EECS3311, the prof will be also assigned to Jackie objects. So now, do we have aliasing? Yeah, absolutely. Let me just make sure it's not really up. Yeah, exactly. You see the next line is telling you there's an aliasing going on. Because when you see this line here, EECS2030.getProf. So every time you see the dot, let me remind you, you need a dot very badly today. Whenever you see dot, that means go to the address that is stored in this particular variable. So now EECS2030 stores some address and go to that particular object, okay? And then go to that particular object and get prof. Get prof is simply just going to return back to you the address of this particular prof, right? It's referring to this object here. Similarly, if you say EECS3311 get prof, it's going to EECS dot, it's going to follow to this particular object, get prof is going to follow to also the same objects. So we talk about the same address over here, okay? So now, if you try to evaluate this equality over here, should it be true? Right, because you refer to the same object. I want to make sure. Okay, this first one is very easy. So now, let's proceed, okay, if you have no questions. If we proceed with this, and then we simply say prof over here does set name. Prof is a context object over here, and then it's referring to this particular address that's being stored, all right? When you say prof does set name, if you look at the set name over here, it's simply going to assign the name to whatever we say. Let's say Jeff, okay? In that case, before I change the diagram, after this particular call to the mutator, are we going to modify the instructor for both EECS2030 and 3311, or only one of them? Both, right? Because both of them pointing to the same object. If you update it, it's going to be affected for both. So now, when we say now prof does set name to be Jeff, so that means prof set name to be Jeff. So now, the instructor for both courses, now Jeff, okay? So now, if you try this, okay, number one, if you try this, let me just use highlighter here. If you try sorry about that, highlighter here. 2030.getProf, EECS3311.getProf, it should be still the same, right? They still refer to this particular faculty objects, so that's not a problem. So check, it's going to pass. And also 2030.getProf.getName should be Jeff over here. Okay, very good. Guys, so far so good? Okay, I want to make sure you're comfortable with this. This is only a warm-up, okay? And then let's see the last portion of the code. Let's do that quickly. The last portion of the code, we are introducing a new faculty object. Let's say prof number 2, okay? So prof number 2 is going to point to a new faculty object, let's say with name Jonathan, okay? So what I will do is I'll copy that object there. So a new faculty object here, and then is now pointing there. The name is Jonathan. Okay, so John over there for short. So now, how do we visualize this line of code? When I say EECS2030, that said prof. What am I changing over here? Am I, yeah, which pointer?
Prof and EECS3030.
Yeah, exactly. So now the context object is very important. Okay, just do that together with you. You can see EECS3311, that is a context object. So we talk about this object over here. So now it's prof rather than pointing to Jeff. It's now going to point to, okay, this particular prof number 2. Okay? So now, important question for you. Got 3 more questions before we end this example. Number 1, EECS2030 that get prof is going to give you the address of some faculty objects. EECS3311 that get prof give you another objects, right? Do they refer to the same objects? Easily to tell because let me just use a laser pointer. EECS2030 get prof is going to follow the pointer which will give you these objects. On the other hand, EECS3311, if you follow the prof, is going to give you, sorry, wrong way, this object over here. Okay, different objects. So that is why you see not equal to. Okay, very good. What about this guy here? That should be very easy. I want to get a name for EECS2030. Should be Jeff, right? Because you follow the pointer, it's going to tell you it's this object over here, it's Jeff. On the other hand, if I say EECS3311 get name, that should be Jonathan. Because you follow the pointer over here, it's going to tell you it's Jonathan. So this one here, nothing really new. Okay, let me just summarize what you should know from this example here. Number 1, how aliasing occur, you should really know. Okay, number 2, if you check for every assertion we have over here, make sure you understand why it should be true, why it should not be true. It's really important. Okay, that's pretty much what we talk about for your lab test 1. So hopefully you're comfortable with it. Okay, that's the first example, and then we might do a second one over here. Okay, so now the second one over here is actually quite straightforward. It's very similar. The only thing I want to show you is how you can visualize it. Let me just tell you, this one will be very similar, so I don't want to trace it completely to waste your time. I want to highlight the thing you want to look at over here. Number 1, notice that when we say student class, the student class over here, okay, notice that we got some ID for the students, and then this is important with an array list of course and then CS. We talk about array list in the collection lecture, right? So now, by passing over here course, we're saying that every member, or every element, let me say elements, that might be making more sense. Every element in the list are of type course, because we instantiated this particular generic parameter by course, right? We talked about it before, right? In some way, it's very similar to the array of course, very similar. It's just now we use array list since you're familiar with it, okay? And then we also have the normal mutator over here at course, okay? Also, we can say get all the courses. So now by using array list, it's actually very easy to implement. In order to add a course into the students, you will simply say courses.add. We talked about add as well, right, in the previous lecture. And also, if you simply want to return the list of courses, you can say return CS, right? Of course, if you use the array, you have to use a loop to gather all the courses by filtering out the null slots. Okay, similarly, you can also see the faculty over here, where every faculty member, they have an array list of courses, being their teaching load, for example, right? Every student has a list of courses. Every faculty also has a list of courses, and they might be shared. They might be. Okay, maybe I should visualize that for you just to see. Okay, and then, okay, anything else? Okay, you can say add teaching over here, and then we'll say add. Also, return all the teaching load for this particular faculty, you will say return TE. Okay? Guys, are we okay? Let me visualize this very quickly. I think it might be worth doing. Okay. Let's try the following. What we will see is we're going to see that somehow a particular course can be shared by a student and also by the faculty object at the same time. We want to make sure we know how that happens. It's very common. Okay. That's just another case of aggregation because we got sharing, we got aliasing. Let me do that quickly for you. Okay, the first one, let's say faculty P. Also, I will put myself over there. So let's say we put the faculty over here. Okay, I'll put it here. Just be careful. Okay, and now that's faculty P. So P is pointing to this particular faculty objects with name Jackie. And now remember back in your programming pattern, when we initialize the array of courses, we simply say maybe it's an array of size 30, and all the slots are simply null. In the case of the array list, we simply create an empty array list. If you look at that, I'll show you. If you look at the constructor for the student class over here, you can see we simply say CS is assigned to new array list. So that's an empty list to begin with. Okay? So now what I will do is I'll simply say it's just empty. It's pointing to something, but that's empty. Okay? And then I'll do another object here. And the second line is going to be S of type students. Okay? And of name Jim. And then I'm going to create this particular students. Okay? Let me put him on the bottom here. Okay? There's a student object here. And then there's S. Okay? There's a pointer. Let me write it more carefully. S pointing to the student here. And then we got Jim as an ID. And similarly, the list of courses would just be empty array list. Okay, if you look at that, this is empty list, and this is also empty list in both cases. Okay, so now let's do a little bit more work before we try to see the interesting stuff. I want to create two course objects over here. I want to get 2030, I want to get 3311. Okay, let's do that quickly. We did it already, just for completeness. So I'm going to create two course objects over here. So one over here, another one over here. Okay? And let's get a pointer right. So one is called 2030, the other one 3311. So EECS2030 is pointing to this object here, and EECS3311 is pointing to this object here, right? Good. And then the title, I'm just going to omit it, so you can easily see that. That's not a problem. Okay? And now for prof, it's still null in the beginning, right? We haven't set it yet. Okay. So now this here comes the interesting bit that we're going to trace. We're going to consider all these lines over here and see how the pointers are going to be shared, are going to be filled around. Okay, let's do one by one. In order for you to review later, for you to review it more easily later, let me number them. Let's say this is number 1, number 2, number 3, number 4, number 5, number 6. Basically, all these 6 lines, we are not trying to create any new objects. We're just changing the pointers around. That's all we are doing. Okay? Let's see how we can do it. And when you review the example, I would suggest try to find a piece of blank paper and try to do this by yourself. Okay? This one first. Set the prof of 2030 to be P. So 2030 is over here. The prof should be the faculty P. So now I will do, let me just do this way. Okay? It's now going to point to this faculty object, right? And then, so that's number 1. Number 2, we want to set the prof for 3311 to be the same prof. So now 3311 is here. The prof is now going to point to this guy here, right? The same objects. Now we get aliasing already. So that's number 2. Okay? And then let me change color. And then number 3, we're going to add a teaching load for this particular prof, right? Context object is simply P. So now eventually we're going to make sure myself, I got 2 courses assigned for me to teach, right? 2030 and 3311. That's what we'll see. So eventually you will see that this list will simply grow to be of size 2. Each one of them is going to store the address of some course. The first one to store will be 2030. So the first one is going to point to 2030 over here. So that will be number 3. Okay. So this is number 3 over here. And then number 4, we're going to add a teaching load to myself, again, 3311. So that means the second element in the list over here is now going to point to this particular course. Okay? That's number 4. It's complicated, but hopefully not messy, right? That's basically what you have to do, how to set things around. And then let's do the final 2 steps, and then we can talk about aliasing. The final 2 steps, let's see this. So the context object is now S, the students. We're basically going to add the courses to be registered for 2030 and 3311 to these students, right? So we talk about S, which is this student over here. So now eventually we're going to add 2 courses. So the list, array list will be grown to of size 2. Okay? The first one to add will be 2030. So that means I'm going to make sure the first course is now going to point to 2030 course objects, right? So that would be number 5. And finally, for number 6 over here, add 3311 to that students. So that means it's going to point to 3311 students. Guys, any questions so far? Okay. Of course, when I do it while explaining to you, it'll be slow. But when you do it, hopefully you can be quick. Okay. Let's just try different stuff over here. Okay. Number 1, to check for aliasing. Can you imagine whether this expression will be true or false? When I say EECS2030.getProf, which will give you some faculty object address, would that be the same as s.getcs.get0.getprof? Okay, let me just trace a little bit together with you for the first one. Okay, the left-hand side is easier. You simply go to EECS2030 over here. So that's referring to this particular objects. And then you want to get a prof. So simply follow the prof link. You're going to get to this particular faculty objects. Okay, that's the first answer for the left-hand side. That's easy to follow. The second one is a bit more interesting. The second one there, if you analyze it a little bit further, s.getcs. Just this alone, what would it give to you? If I only say s.getcs, well, would it return a single course or multiple courses? Multiple courses, right? Because how do you tell? It's very important for you to look at the API. So if you look at the getcs, it's exactly over here. Getcs returns an array list. Okay, that is why. So this itself will be an array list. I'll say AL. Okay, and then because that's an array list, you can say go to the element at position 0. Okay, and that one. So this part here is going to give you an array list of course. Oh, sorry. Yes, an array list of course. And then if you try to go further, this get0 is going to return to you the course at position 0. So this part here is going to give you a course. And then for each course, you can call getProf. I'll give you the faculty object, right? Let's try to follow that. So let's try this one time. S is over here. Oh, sorry, highlighter. S is over here. S dot CS, basically get the courses, right? Is going to refer to this particular array or array list. Go to position 0, which is here, and that one there is going to follow the link that will give you the prof. If you want to get a prof, you'll follow the same link over here, so that will give you the same. So they refer to the same faculty objects. Okay, so that's why this particular expression should evaluate to true. Guys, any question here? Any questions? So you'll be comfortable if I put something like this, right, in the written test. You'll be, okay? Now you can say no. Then I'll try to explain more. If you say yes, then I'll be confident to put it. Okay. I'll put it anyway, that's true. I'll put it anyway, that's true. Guys, seriously, any questions? Yeah? No? Okay. If you have a question, as ever, come to me for help. Okay? So now, to really not to get you too bored, I'm going to leave the rest of them as the exercise for you to trace them. Okay? Basically, you got all the diagram ready for you. You can draw it by yourself and then follow the link to see if all the sessions should pass. I can tell you they should, but you're going to find out why by yourself. All right. So now, So far, what we have done was we gave you aliasing situation just because we gave you the methods and then try to trace them. But now we do things a little bit backwards. I'll show you some object diagram, and then I want you to define some methods based on that diagram. We do it backwards to reinforce your understanding. Okay? Let's see how this can be done. That will actually help you when you implement your Java classes. Okay? Especially you got multiple classes. Let me go over a little bit slides with you. Oh, that's the example we just talked about, so you don't have to worry. It's been covered. Okay, that's the example we just went over. So now, this kind of situation is very common. So for this course, at least in my section, I want to show you really a little bit closer to reality. You have to deal with multiple classes. When you got multiple classes, how can you actually try to get access to other classes in the same system? For example, if I am in this particular student class, let's say this student is taking two courses, 2030 and 3311. I want to know what is the first course taught by the instructor of the first course of these students. It sounds a little bit complicated, but that's kind of the code you want to know how to write. But we're going to focus on that for the example. Okay? But when you see this, let me just show how to read it quickly. We're saying that every student has an array of courses over here, and every faculty contains a list of courses being their teaching load. And also, every course has a single professor, faculty object as their prof, like an instructor. So you got three arrows over here. So now we're going to see how we can play with these and let you write some code. Okay, we'll write it together. Okay, that's kind of an interesting exercise to do. Okay, so let's assume the following. So let's say we got student class where we got ID, the name, and also we got an array list of courses. Okay. Also, we got a course where we got title and we got prof, okay? And also we got faculty where we got name, and also we got an array list of courses being their teaching load, or just a TE for short, okay? And now what we want to show you is at the runtime, every time you got aliasing, kind of like a link, you can follow the link between classes. It's something sometimes people call navigation, okay? We're gonna see it's kind of fun to do. Okay, so now, for example, in the student class, if you simply say CS, it's talking about the array list of courses, right? On the other hand, if you say CS at position I, or get I, it's going to tell you where, at the particular position of the list, what's the course objects, right? Anyway, let's see example together, okay? Okay, I'm going to guide you through the exercise over here, so don't worry. It looks a little bit overwhelmed, but it's not, okay? So now, let me give you the following question. Assuming that we got these three classes, okay? Now, I want you to extend the faculty class by a single method. Okay, we're focusing on this particular class. We call it the context class that we're talking about. I'll give you some example. Let me just go through this diagram very quickly with you, okay? So we got faculty objects, two faculty objects. We got F1 and F2. Also, we got two course objects over here. We got 2030, we got 3311. And also, we have a single student object, which is S, okay? And then, for Jackie here, he's only teaching one course, 2030. For Jonathan, he's teaching also one course, 3311, okay? That's for this particular scenario. And also, for Jim, the students, he's taking both courses. Okay, that's a scenario we are focusing on, okay? So now, let me give you the example of the method you want to write for me. Okay, I'll give you example. How can you call the method? For example, if I say f1.getName, it's going to tell me it's Jackie. If I say f2.getName, it's going to tell me it's Jonathan. So now, this is the getName method you want to implement. What will be the implementation? Return something. Return what? Return how? Just tell me the code to write.
Okay, just return this name.
Return this.name?
Yeah.
Yeah, that's good. The first one is very trivial, but that's easy. Because for the first one, in this particular faculty class, we already have the name attributes. We don't have to navigate just yet. We will in later example. So this one, very easy. We'll simply say return name, or this.name. We're just referring to this name over here. The first one is very easy. So now, I want to keep in mind, I'm going to give you 2 more methods to write from different classes. But eventually, the information we want to get will be Jackie and Jonathan. But we're going to get it in different ways. Okay? Keep that in mind. Second example. The same diagram. Okay? So now, let's say I want you to focus on the course class. And then I want you to define the getName method. What this will do is, I want you to return, let's say for EECS2030, return the name of the prof. I don't want you to return just the object back to me. Return the name of the faculty. Okay? So now, for example, if I say EECS2030.getName, it's going to somehow tell me it's Jackie. If I say EECS3311.getName, EECS3311 is over here, somehow it's going to give back to me Jonathan, as opposed to this object here. It's different, right? Rather than returning the faculty object directly, I want you to return back to me the name of the faculty objects. How do you write this code here? Return what? I can tell you that if you simply say return this.prof, it's wrong. Because this.prof is of type faculty, which doesn't match the return type string. I got somebody here. Yes? Okay, let me write it down. Okay, I will write down exactly what you said in verbatim. You were suggesting return this get faculty. Is that what you said? Okay. Dot get name. Okay. I want you to maybe stay with these particular definitions over here. So now, for example, let's see this. Do we actually got a get faculty method in this course class? We don't, right? Okay, I'll let you try a second time. Stick with what you have got in this slide over here. Why don't you try a second time? But you're getting there. Guys, I'll let you try the next one. Okay. Okay, if you say, you mean this get this faculty? Okay, I'll write it down, and then dot. Something, right? Is this right, though? If when you say this, you talk about this particular context class. Do we have a faculty attributes? No. You can either say this.title or this.prof. That's the only thing you can say to navigate. If you say, let me say, I'll point to you. If I say, for example, if I say this.prof, I'm basically saying this.prof. I'm following this link and go to this particular one. I'm navigating. Okay, anybody? Just try to give me the correct answer. Yes?
Is it faculty.getName and then prof constructors?
Just tell me what to write for this particular line. What should I write? Okay, return. Okay, we know that this is not quite right. Okay. Return. Again, we don't have faculty, do we? This.prof dot maybe name, right? We want to stick to the class, right? Only, of course, you might assume that we got a get name method. Let's say we don't assume that. Oh, the slide. Okay, let's just focus on the slide here. But I see what you mean. Okay, the correct answer should be this.prof.name. Okay, this is talking about this course over here. Prof is talking about this attribute here, which referred to some faculty. So now we switch the context to faculty. And then name is referring to this name, which is a string. If you look at the diagram, we talk about, for example, let's say for this guy here, right? Let me write down the definition. I want to make sure it's right. Return, let me write it again. Return this dot prof dot name. Okay, if you think about it, context object here is EECS2030. So that means we're going to replace this by EECS2030 at the runtime. Okay? And now, the context object over here is 2030. So EECS2030 is referring to this object here. When I say .prof, it's now going to follow the link all the way to this particular faculty objects, right? And then I say .get name. It's going to follow the name, and then go to Jackie. Guys, make sense? Okay, if you try the second example to say EECS2030 name, it's going to be the same. You can see this second example there, don't lose the big picture. We are basically getting the same information, either Jackie or Jonathan. However, the context starting from which we get this information is different. So the context clause is really important. Okay? Question?
Don't have a piece of shadowing from basically just say this dot from just say prop dot.
Oh yeah, exactly. You're exactly right. So what you just pointed out is absolutely valid. Let me just repeat that for your colleagues. So what you're saying was, is it okay for me to say prof.name? The answer is yes. Yes. You only need to put yes if you want to distinguish between the name and the parameter, right? But in this case, yeah, that'll be fine. You just make it easier to trace. I can replace this by the context object, right? Just easier. Yeah. Guys, are we okay? Let's do an even more complicated one. You can predict what's going to be the next context. Students. Let's try that. Again, what we will see eventually is, I still want to get the information for Jackie and Jonathan. But now the starting objects will be the students over here. And now you can see that the method here is still called getName. However, the parameter is a little bit different, right? Previously, there was no parameter. But now we do have a parameter. Let's see some example over here. Let's say I say s.getName. Okay? S is referring to this student here. When I say getName, what that means is go to the first course of the students and get the instructor's name. You see what I mean? Okay? Get the name of the instructor of the course stored at position 0 of the student's array list. Okay? And now let me follow the link just for you. Okay? Just quickly. If I start with S over here, and then if I go for its courses array or list, and now I want to go to position 0. Position 0 is pointing to some course over here, but I'm not done yet. I want to get the instructor's name. How do I get the instructor? Follow the prof. And then faculty, am I done yet? Not yet. I want to get the name. Quite a bit of dot notation you have to use. So now, please, you want to suggest something? Okay, let me try. Okay, can you repeat again? I want to repeat verbatim. Return. CS, okay, since now we talk about array list, right? So you want to get which index? Well, remember we are programming the method, right? So whatever, don't put 0 always. You should say I. Okay? Get I, and then? Mm-hmm. That's 100% correct. Guys, are you okay with that? Let's see how we can trace this. You can see it's a different exercise over here. And this is actually more important because most likely beyond this course or towards the end of the course, you have to know how to write this kind of notation. Dot notation is a very unique phenomenon for object-oriented programming. I would say it's maybe second most important. Most important is inheritance. Second most important is dot notation. Okay? All right, so now let's trace one of them together. So now let's try this. And if you don't mind, I'm going to just put this guy here. Okay, I want to make more space for us. Okay, I'll move the example here, if you don't mind. Okay, so now I want to rewrite it quickly. I want to put this into context so it's easier for you to see how I trace it. So I'll simply say this dot cs dot get I dot prof dot name. Okay, let's trace just one example. Okay, let's say I want to trace this guy here. Oh, actually, you know what? Let's try something more interesting. Get 1. Okay, so now s is now the context object. So we're going to replace this by s, and the argument value is 1. So it's now I is going to be 1. So it's going to be 1. Okay, let's try that. Again, let me just use a highlighter so you can see the path exactly. We started with S over here. Dot is going to give you this object over here. And then CS is referring to these attributes. Dot is going to follow the link and go to this particular array list. And then you want to go to position 1. Position 1 is talking about this position over here, right? Oh, thank you. Yes, yes. Thank you. Yeah. Sorry. Yeah. 1 over here. And then you say dot. So you're going to follow that link. That will give you this particular course objects. And then you say prof. So that will give you this particular attributes. And then you say dot is now going to follow again the link to here. And then name. Right? Just this object here and the name. You get Jonathan. Okay, any questions? So now we do have one challenging exercise for you, a slightly different method. Any questions before I give you the exercise? All right, let's see the exercise for you. This one, the context class to look at would be the course. The method is called getTitle. Okay, I'll give you one example. If I say EECS2030 and getTitle and then 1, what I'm trying to say is go to the instructor for 2030. And then for that particular faculty member, I want to know what's the title of the second course they're teaching. Because if you say EECS2030, once you get the instructor, the prof, each faculty has a list of teaching load, right? I want to say go to index 1 for that particular teaching load and see what's the title of that course. Okay? And let's just see one example here. If I got EECS2030, so that means I'm here. And then if I go to the prof over here, I'm basically going to this particular faculty. And then I want to go to this particular index, right? Index 1 over here. That's referring to this particular course. And then what's its title? Software design. Okay? How do I implement this method? Okay? Think about it. Think about it. What should I write? I want to, hopefully you can be 100% correct the first time you say it, right? You can see the trick. The trick is you want to follow just the attributes, right? To do navigation. Anybody other than Stefan? I know Stefan knows the answer. I'll point you next time. Okay, please. Return? Yes, just tell me what to write. I will start with this if you don't mind. This dot .te, I like that. Get I, yes. Title. Okay, anybody disagree? That's correct. Pretty good, very nice. Okay, so now let's just double check with one example. So now if I try this particular example over here, EECS3311 getTitle 0. How do I trace it? So now this would be EECS 3311. And also the I here would just be 0. Okay, let's try that. So now if I say okay, let's try. EECS 3311, so I'm talking about this particular course objects. That prof is now going to follow the prof link and go to this particular faculty, right? And then you say .te, and then you go to te, the array list, and go to position 0, which is here. And then you say .title, so position 0 is referring to this particular course objects. And then you say .title, it's going to tell you title is Advanced OOP. Okay, that's correct. So do take these 4 examples that we talk about, think about it. What we're really doing is, based on what you have declared as attributes, which are reference type, how can we navigate? Okay? So that's why the diagram can be useful, right? You can see how to navigate. Direction is really important. Guys, any questions about this? You okay? Okay. So when you look at the slides, that's exactly what's in the slide. I just finished all the example. You can look at that. There might be one or two simple ones I didn't cover, but you can look at them when you go over the slides, okay? Everything has been covered up to now. So now we can talk about composition, okay? One thing I want to note is over here. You can see that over here, we are basically saying the following. Every directory contains, but did you notice that there's a solid diamond shape as opposed to empty? Solid simply tells you it's composition, which means every directory contains multiple files. Each file may also have some directory as parent, but for this directory, you don't have to worry. I'm just put it for your information. Focus mainly on this. Every directory contains multiple, one or more files. However, the diamond shape that's solid here means there should be no sharing, no aliasing. If you can see any aliasing that's possible, then that means your implementation for the composition is invalid. We're going to see, okay? Let's try to see that. Okay, basically we're saying that the files are not shared among directories, right? That's why there's no aliasing. Okay, we're going to see some code. Let me go over some code with you quickly, and then we're going to see different versions and trace it. First of all, let's say we got a file, and then we got the name of the file, and also we have a simple constructor, just initialize the name. That's it. File class is very easy. Let's say we have another class called directory or folder, and then we have the name, and also we have an array of file, and also number of files. That's the pattern you're very familiar with. And also we got directory, which will initialize the name, and also simply initialize the array to be of size 100, let's say, up to 100 files. And then we also got add file, okay? Add file over here, we simply take the name of the file, which is a string. But now we want to add file objects into the array. How do we do that? We simply say the position NOF should be assigned to new file and file name, right? It's very similar to what you have done in lab test 1, okay? This first example, I just want to show very quickly how to visualize it and to see why composition is achieved over here. And then we try to extend it a little bit, okay? The first one here, let's just go over some, okay, that's basically the one I showed you on my desktop last time, right? You got a folder called D, and then F1, F2, and 3, okay? Let's see how we can run the code quickly. Quickly. Okay, so now I already got some diagram drawn already, so that can save our time. So now we have already seen directory, we have already seen file, okay? Let's trace this piece of code quickly, okay? So now the first line, you have over here, directory D1 is a new directory. So D1 is a new directory over here, right? The name is simply D. That's been done. And then you have basically D1, let's see this. D1.add file f1.txt. Let's trace the first one very quickly. So that means I'm calling this add file method for the first time. And now the name should be f1.txt. And now the first line over here, first of all, the right-hand side, I'm trying to create a new file with f1.txt. And of course, this in turn is going to call this constructor over here, right? And that one there should be f1.txt, and just create it. And this is what you will do eventually. You can see there's a file object over here, and then f1.txt. Okay, very easy. And now the only thing we have to fill in is this. So now, when I say this new object, its address should be copied to NOF, at the moment it's simply 0, right, to begin with. So that means now it's now going to point to this particular file object. And then after that, we're going to increment it to 1, right? Hopefully you're okay with that. Okay, now I'm going to just do the others. Second one and third one, we're simply going to make sure eventually NOF will be incremented once and twice, right? 0 to 1, 1 to 2, and 2 to 3. And then 1 is going to point to f2.txt file objects, and 2 is going to point to f3.txt object, right? That one's easy. Anybody having problem with tracing this? Okay, this one is nothing new. Okay, and now we can do a very simple assertion. Okay, we can simply say d1.files at position 0.name. I'll leave it to you to convince yourself. It's really referring to f1.txt, right? That should be quite easy to follow the dot, which we did extensively so far already. So now, I want you to see one thing here. Is there any aliasing at the moment? No, because if you look at that, only this particular directory is using this particular file, right? Nobody else. And also this one independent, this one also independent. So that's composition. Okay, that's good. That's intentional. We start with something that's correct. But now, we're going to introduce a new concept called copy constructor, which means the way we create a new directory over here, if you look at the first constructor, the first version, we simply give you a string name. What if the parameter type is another directory? How do we create a new directory from another directory? You want to think about that, okay? Let's see that. Okay, let me go over some slides with you. You know, I want to just illustrate to you on my desktop, if I may. I hope I didn't delete it. I have. Okay. Basically, every time if you try to copy and paste a directory, you should copy all the files in that directory and paste it, right? So all the files should be independent. Okay. I don't need to bother you with that. That's quite easy. I want to show you some slides about copy constructor, and then we'll do some example. Okay. So these have been covered already. That's a diagram. Okay. Now, how do we do copy constructor? Here's definition for copy constructor. A copy constructor is a constructor which initializes attributes from the argument objects other. So for example, you can see for directory class, we have this constructor here, directory. Its parameter is simply just another directory. Okay? So now I have a very naive implementation for you, even before I go to the example. Okay? Very naive. Okay? So what I would do is I'm simply just going to copy this guy here. Can I paste it? Did it work? Okay, never mind, doesn't work. Okay, what I would do is I'll write it down over here. Oh, actually, can I say, sorry. Let me delete it. Let me present to you one version of the copy constructor. So we have the class, and then directory. And then I have my copy constructor over here, directory. And then also the type of the parameter is also directory. I'll say other. Okay? What I would do is I'll simply say this is assigned to other. Let's now, I just want to present you conceptually. Okay? If I simply write something like this, would that work? Just conceptually. Would that actually give me something without aliasing, though? Would that? Yeah, because in here, I'm only copying the pointer, right, over here, the address. Basically, what this is saying is, imagine that if I say directory over here, D1 is new directory. And then I'll just give a name, let's say D1. And then I'll simply say directory D2 is simply new directory. And then I'll simply say D1. Think about what this is trying to do. Basically, what we are doing here is, because you're simply saying, I'll simply assign this, which is the object we are trying to create, and then simply assign that to whatever parameter you're passing by address. So it's as if you got D1 over here, which is pointing to some directory objects. And then the way you create D2 is by saying D2 is also pointing to the same directory objects. It's a very naive implementation. But this one here creates aliasing right away. Okay? So that one's not going to work. So it's not composition. Okay? Anything you change on the directory using D1 can be reflected on D2 as well. Okay? Anyway, that's one I want to show to you. It's not really on the slides, but I want to show you quickly. So now let's look at something that looks correct but may not be correct. Let's see this. There's something called shallow copy. I'll explain what a shallow copy is in just a moment. Let's see the code. Let's say we got our directory class over here, and then we define this constructor here. Okay? What we will do is we're going to make sure the number of files for the current directory we're trying to create will be assigned to other.number of files. Make sure the attribute is copy over. Okay? And then we'd say the name of the current directory we are creating should be assigned to other.name. And also we say files, the array of file, should be assigned to the starting address of other.files. That's what we are doing. Okay? I'm going to trace this and visualize for you. Okay? But now, do you see any possibility of aliasing in this version over here? Aliasing. Specifically, is it possible to have the files being shared by the two directories? Is it possible? That's a question. If you think yes, you're right. But if you think no, that means you may want to visualize this a little bit to convince yourself. Okay, let's try that. Okay. So this is one so-called. I'll explain what shallow copy is once we trace it. Okay. Let's see some example test case over here. I'm going to trace that together with you. Okay. First of all, the answer is no. It's not going to implement composition because you got aliasing. But let's see why. Let me switch the context to iPad. Let's see this. What we will do is, first of all, we are trying to create D1, and also we are trying to add F1, F2, F3. It's been done already. Okay, you can see D1 directory, 3 files, and also F1, F2, F3. That one's done, so we save time. So now the line that we want to look at is here. Okay, look at that. I'm trying to create a new directory called D2. And the way I do it is by calling the directory constructor, the second version, where D1 is simply of type directory, right? So that means it's going to call this particular version where it's directory, first of all. Okay? So now, how do we trace this? How do we do that? We're going to execute line by line, for sure. Okay? If you think about it, let me just add this just for a little bit more information. You can think about NOF over here is this dot NOF, and also this dot name. Okay, you don't need it, but it will help when we trace. So now the context object over here is basically the new object that we're talking about. So now we are talking about creating this particular new directory. Eventually, we're going to call it D2. Okay, I'll just say D2 here. Okay, so you can think about that this over here is simply just going to be D2 eventually. And now what about other? Other is simply D1, right? So other will just be D1. And then other will just be D1. Other will just be D1. So what we, and also other will be D1. So what do we have to execute here? I'll write it down. You have to say over here, D2.name is assigned to D1.name. That's the first line. And then you have to say, oh, NOF. Sorry. Let me write it down. Just got the sequence wrong. You got to say D2.NOF is assigned to D1.NOF. The second one over here, D2.name is assigned to D1.name. And also D2.files is assigned to D1.files. Okay, so these are the 3 lines, 1, 2, and 3. Does any line over here create an aliasing amount of files? Which one? Think about it, okay? Can one create aliasing among files? Number 1. Let's see what the 1 will do. Number 1 is going to say D2.NOF. It's going to copy over D1.NOF, which is 3. Just copy that over. That one, no aliasing among the files. Okay? And then let's try to see number 2. D2.name which is referring to this particular attribute over here, is now going to copy the address of d1.name. d1.name is now currently referring to this particular string value d over here, right? So now that means it's simply just going to point to the same object as well. So string is a reference type, don't forget. So we can also have aliasing. But having aliasing for string is not our concern over here. We worry about files. What about the third line? Is it going to create aliasing for files? That's a question. Okay, let's try. Let me draw the diagram here, and then you can tell me why this is aliasing. That'll be very useful. Number 3, we say d2.files, which is referring to this particular link, is now going to copy the starting address of d1.files. d1.files is now referring to this array over here, right? So now, that means conceptually, let me draw it the other way. It's now going to point to this particular array. Okay, let me draw a little bit better. It's now going to point to this particular array. So now, do we have aliasing for files? More precisely, is this particular file, for example, being shared by the two directories? Yes, right? Okay, let's double check. Okay, it is indeed. Because if you try the following Boolean expression, let me do that. If you try d1.files equals d2.files, would that be true or false? True, right? d1.files is referring to this particular address. d2.files has been also pointing to this particular address. So that will be true. And this already tells you anything that happens below this particular array will definitely be aliased. Okay, let's try that. I'll just give you one example. If I say d1.files at position 0, that's f1.txt basically, equals d2.files at position 0. When I say equals, would that be true or false? True? Yeah? Let's see. Let's see this. I will try to use a highlighter here. Okay, so now when I say d1.files is referring to this, and then I want to refer to basically position 0. Position 0 is referring to this particular file, right? That's what I'm having. What about the right-hand side? If I say d2 over here, .files is referring to basically aliased into the same array over here. And then I say position 0. Oh, that will give me just the same file. So this is aliasing, this is sharing of the file. So this is not good for composition. So now you have two directories sharing the same file we don't want. Okay? So this is so-called shallow copy in the following sense. You can also refer to the slides. So this is called shallow copy simply because the way we implemented the constructor was like this. We simply say it's assigned to, and also it's assigned to. That means the way you actually do the copy constructor is simply by assigning one attribute to another. Okay? So now all these are just shallow copy, just using assignment. And in this particular case, this will give you aliasing. So this shallow copy is not the way to go to do composition because you got sharing. So now, how do we actually can get it right? I don't want any files to be shared by the two directory. Any suggestion before we see the solution? Suggestion?
Making new arrays.
Making new array, I agree. At least the directory number 2 should really contain another array. I agree. What else? We need a for loop. What about each iteration for the for loop? How do we make sure we can somehow get a copy of F1? That's the question. What you were suggesting was something like this. Let me reverse my presentation a little bit. What you were suggesting was like this. Okay, let's go over that quickly. Okay. This is a copy constructor. Everything else is the same. Okay. We still have our directory copy constructor over here. It's taking one directory over here. Okay. I'll explain what this means in just a moment. somehow we have a for loop over here. And then we simply say every file that we want to add to this particular new directory, we simply get a file from the other files directly. You can see this only some address copy over here. But let's see why this is happening. Let's see. Okay? Let's trace this version over here completely. But I can tell the conclusion right away. This version over here is not going to achieve composition. We still get sharing. But let's see exactly how. Okay? Okay, let's try to trace it quickly. Okay? This sounds a little bit maybe new syntax to you, just for your information. So if we try to trace the first line, okay? Okay, by the way, so over here, up to now, this setup over here is the same as before, so we don't have to worry about the same setup. So now what we have to worry about is this line here. Directory D2 is assigned to new directory D1. Okay, that's what we want to trace. Let's see how we can do that. So now if you try that here, we're going to execute this line. Okay, start with that. We can use this over here, but this might be something new to you. After this, we can say parentheses and other than name. Okay, for those of you who didn't know, this is calling another constructor in the same class as a helper method. That's what it is doing. Okay, so let me write it down. So this guy here is really calling another constructor as helper method. Okay, that's what we're doing. Let's see this. Other.name is of type string. Is there another version of constructor which takes a string? Yes, exactly over here. So that we're calling that. And that one there is simply just going to initialize the name and also try to create a new files array. That's what the green one is doing. Okay, let's do that. So that means what we are having here, eventually we want to get D2. Okay, I'll write D2 over here so you know there's objects. And now for this single line over here, we're calling the first version of the directory, which is not copy constructor. We're calling that as a helper method. That one there is simply going to create a new string, so there's no aliasing for the name, and also creating new files, so there's no aliasing on the array. Okay, what that will do is, first of all, copy the name, which is D. Okay, just say a D. It's a different string. And also, we're going to copy the also the files. Okay, it's going to be a new array. And that one there is going to say this is going to point to, okay, let me be careful here. It's just going to be an array, separate array, 0, 1, all the way to 99. Initially, NOF is simply 0. That's what the green does. Okay, it's just calling that as a helper method. And now, as you suggested, we're using a loop over here. Okay, let's go over the loop very quickly. And maybe you'll realize right away once we visualize what the problem is. Okay? So now what I would like to do is I'm going to use blue here. So we simply do a for loop, and then from I0 until NOF, right? That's a pattern we talked about before. Okay? And then let's see what's going on here. This line here. This line is really critical. We say that we're creating a new source file. We're creating a new file object called source. I'm going to write it here. It's going to be src. And what's src? src is going to be other.files at position I. Okay? What is other? Because we are calling D1 over here, so D1 is other, right? Just don't forget. So D1 is other. And then executing this line over here, I'm going to write it on the top. For the first iteration, you're basically saying file source is assigned to other, which is D1. D1 dot files at position. Let's assume we're doing the first iteration, which is 0, right? What does this do? Is it trying to create a new file? Not really, right? It's assigning the reference, right? What it's doing is src now is now pointing to D1 dot files at position 0, right? So that means source is now going to point to this particular file, since there's already some aliasing going on. And then, don't worry about this line, it's not there, okay? Let's look at the orange. what does orange do? You're trying to say this dot add file, and then I simply add source. If you try to say, what's this? This is D2. So if you say D2 dot add file, and then source, what it does is it's going to call the add file, which is over here, right? We typically would know how to do it, right? If you simply say D2 dot files at position D2.nof, and then it's assigned to whatever the source is. Okay, that's the interpretation you are familiar with. Does that create aliasing? It does, because now you're saying at position 0 is simply just going to point to the same file. So now, even though the files array are different, but now the file they point to are the same. So you're not achieving a composition just yet. Okay? Okay? Guys, we're almost done. Okay? I know it's a bit long process, but that's something you should know. Okay? Bear with me. So these two files are really pointing to the same object. So now we are not done yet. And to see why this is failing, when you look back to your slides, what you should really see is, I'll show you. I'll write it down. So D2 dot files at position 0 is actually equal to D1 dot files at position 0. Okay, they are the same. So it's a violation of composition. Any suggestion how to fix it? You want to try again? Or yes? Equals method? No, actually what? The reason I'm using equal here is because we want to make sure there's no aliasing. So you cannot get away from that. Any suggestion how to fix this? I would say it's only a single line fix. I'll let your colleague try, and then, yeah. Go ahead. How do we fix it?
You can add file vector rather than adding the source itself to say new file and give it the same attributes as the source.
Yeah, exactly. Basically, you want to make sure when you add a file, you do not add what source is pointing to. Instead, create a new file. Okay? Exactly. So now, we assume you're okay with this not working version, but very close. So now let me go back to the originally working version that I wanted to present first. The only difference you want to see is here. Exactly what you said. Once we have got a source, right? Remember, source is actually pointing to this file over here, remember? So now we're going to say that create another file called nf. nf is now going to point to a new file object over here. A new file object, where the name should be, if you look at the file, okay, you can see that one also copy constructor. You simply assign the name to be the same as before, right? That's f1.txt, so that one is also f1.txt. So you can see these two are separate files objects. And then when I say now this.f file nf, it's not going to add it. So we are going to have composition, right? So now if you let me just get the picture correct. So now if you think about this is the array that we have, now it is going to point to this particular file, which is different from this file here. So they're different objects. That's the correct solution. But you really want to know what's the difference between the previous one and this one, and see the difference. Okay? Guys, any questions? We've got about 5 minutes. I'll see if I can either take more questions. I can start a little bit about inheritance, a little bit. Okay? Yes, please.
For example, if file, the name was pointing to another object, so we have to again make another.
Yeah, exactly. So good question. That is, you're mainly concerned about what if we got aliasing for the name, which is strings, right? That is why you see we do something here. For the file, I also got a copy constructor, right? It takes a file, and then I will say this.name is assigned to new string, rather than just assign to the name directly, in which case that'll give me aliasing, right? Guys, are we okay? All right. Shall we do just 3 minutes of inheritance? Battery running low? Oh, thank you. Oh, you know what? It's good that you remind me. Give me, we got 3 minutes, right? Let me just plug it on. Otherwise, you lose all the recording for today. All right. Oops. Don't worry, if we lose the recording, I will record a lecture for you. No, I'm kidding. No, we're going to keep the recording for sure. Never happened. Right? Any questions? Let's do 3 minutes of inheritance. Only 3 minutes. Okay. At the end of the lecture, I have some handout for you to collect. Not now, okay? Just when you leave, okay? Give me 3 minutes. I'll do some very quick introduction. And then, oh, it's actually there. I'll make it on the table just before you leave. I want to start with inheritance just with some problem description over here. I would say next Monday, we're going to start talking about inheritance. Inheritance is a very hard topic. However, I'm going to go over that very thoroughly with you. I think that's going to benefit you for all the future courses about OO. Okay? For now, I just want to take about 2 or 3 minutes. I want you to read the problem description. So this is the example we're going to use throughout the lecture. We're going to spend about 3 or 4 lectures on this particular inheritance topic. We're going to talk about many, many things. Okay? But it's good to start on Monday. But for now, can you spend about 1 minute just to read this very quickly? Okay? Get yourself familiar with this example. And this is my question to you. You have to design Java classes that will actually satisfy this particular problem. Okay? And that's a handout. You can take it before you leave. Okay? But not now. Okay? Look at that. Take your time. You can make sure you're familiar somehow. Okay? Everybody had a quick read? Okay? Let's have a very quick discussion, just for about 2 minutes. Okay? Now, in order to do this, for those of you who didn't know inheritance, okay? If you know inheritance already, don't answer. Okay? You possibly know the answer. How many classes do you need for this example here? How many? You can just tell me a number. There's no right or wrong answer. Or just stop telling me class name. How about that? Okay, you got a student class. I agree. Should you get a class called name? No, not really, right? Remember, oh, you know what? Let me remind you one thing. Remember in the very first lecture when I reviewed OOP, I said identify critical nouns, identify critical verbs. Nouns may be turned into classes, attributes, or accessors. Verbs might be turned into mutators, but not necessarily every noun has to be turned into something, not necessarily. So now, for example, kinds over there should not be turned into a class, agree, right? Okay. Okay, we got student class, anything else? Student management system, course, anything else? So we got 3 classes so far. We got student management system, we got course, we got students. Tuition, that's interesting. I would say tuition, should that be a class or attributes or method? I would say that one, we can talk a little bit more, but tuition, I can tell you, it will turn out to be an accessor to calculate, because you only want to calculate, right? Here's my question to you, okay? If you claim that you're just going to have one single class for students, just called students, right? How do you distinguish between different kinds of students? Anybody? Let's say you only got a single class called students. At the runtime, you're going to instantiate student to be S1, S2, S3. How do I know S1 is a resident student, whereas S2 is a non-resident student? How do I know? You put a Boolean variable. For example, let's say the Boolean variable is simply say is resident. It will be true or false, right? To be more general, you may have an attribute in the student class called kind, which may set to 1, or 2, or 3. Given that integer is 32 bits, you got 2 to the power of 32 possible student you can save. Sounds to be a working solution. Sounds like. Let me just say one more thing. Give me 30 seconds, okay? If you only have a student class with a single attribute telling you what kind of student this is, it is working solution, but it's a poor design. Okay, I will start from here, from Monday, and then we continue. Okay, get your handouts.